Let's get somebody out there to read that aloud for all of us. Tiana, thanks for volunteering. 650, number 21. All right, so we're going from J to K. Tiana, look at the graph, and what is the point, the coordinate of J? Okay, negative 3, 3. And what's the coordinate of K? 0, all right, so let me catch up with a graph real quick. So there's J, negative 3, 3. And there's K, 0, negative 3. You already have this, right, in your picture, in your book? Okay, so what we're trying to find is whether or not, well, you know what, read the last part of it again, Tiana, nice and loud. Yeah. And so we got to find where we put point P for each A, B, C, D, and E that gives us integers. Okay, what's an integer? It's a non-fraction, but it includes negative whole numbers. Okay, all right, so let's take a look at letter A together first. What's the ratio of letter A, Shaylee? You have to look in the book. Number A gives us a ratio, or letter A gives us a ratio. 1 to 1, thank you. Now, when we have 1 to 1 ratio, we have to put that in fraction form. That means it's 1/2. I have done this illustration before, but I'm not sure I've done it in this class. All right, so watch this. If I walk halfway between here and the back wall, I talked about right here, okay? I'm halfway, right? However, the distance from here to the distance from there is 1 to 1. See that? But I went halfway. Because I add those two together, it gives me a full distance of 2. And there's 1 here and there's 1 there. Okay? All right, let's start again. I'll give you another, use the same concept. Little. Stop. Now I went 1/4 of the way. Okay, that means the ratio is 1 to 3. That went 1/4 of the way. That makes sense? Starting to sink in. I know some of you were having trouble with how to, or why does this become this? And that's why. Okay? All right, so now we know that that's 1 to 2 as a ratio. It's going to be cut in half, basically. All right, so we've got rise, we've got run. Let's find what the rise and run is from J to K. If I'm going from negative 3 across, that looks to me like that's positive 3 units. Wes, you with me on that? Positive 3? All right, how far down is it? Looks like to me it's negative 6. So my rise would be negative 6, and my run would be positive 3. I don't want to go too fast. I want to make sure you're with me. Got it? Okay, so what do I do at that point? Well, remember, I'm not going the whole distance here. Remember, P, wherever I put P, I'm going to stop somewhere. And this one, I'm going to try and stop right in the middle, right, where it's 1 to 1. That's the idea. Okay, so how I do that is I take the 1/2 and I apply it to both the rise and the run. And I see what I end up with. In this case, I end up with negative 3. In this case, I end up with 1.5. Are they both integers? No, they're not. That is not an integer. Okay? And so I'd actually answer letter A with the answer of no. It doesn't work. It doesn't give me an integer. You guys got it? All right, let's take a look at B. What's our, Shaylee, back to you. What's our ratio that they want in B? 2 to 1. Okay, so that means the fraction needs to be 2 to 3. We're okay with that? All right, thankfully we've already done the rise and the run. We're just going to use the exact same numbers for the rise and the run. The rise was -6. We're going to multiply that by 2/3. And the run, move this up. And the run was 3. Multiply that by 2/3. All right, so -6 times 2/3. You could reduce and then multiply, or just multiply across. Either way, you're going to get a -4. And then we multiply across here, and either way, you're going to get a +2. Now, it answers, and so the answer here is yes, because we get integers. But the next level of the question that they don't ask, but we need to know, is where is that point? It's not, this isn't the coordinate. Remember, this is how much it's moved. It's moved 2 units over and 4 units down. So that point would be right there. Looks like -1. -1. That'd be the coordinate. They don't ask for this, so it's not like we're doing anything wrong, but -1, -1. The coordinate B. Everyone okay with that? Chris, you see that? Okay, let's go to C. Back to Shaylee, what's the, you know what? Let's not do that. All of you, do C, D, and E at your seat. Shaylee, do you let me not like picking on you? Are you all right with that? I'm good. Because nobody's off limits in this class, right, Kat? Go ahead and do C, D, and E, just like we did A and B. Those of you virtual, work on this on your own. All right, I just went through all three. If you haven't done them yet, take a look and see. C is a no, D is a no, and E is a yes. Check your fraction work. If you need to use your calculator, that's okay. It's all right. Off, you get all three of them right? Don't lie. Offenbarger. What if I told you to bring it here? Let me see it. No, I'm just teasing. See, that's confidence. Coffee. Coffee. Did you get them all right? That means no. Okay. Any questions? You guys see that? Do you understand a little bit better now? A couple days ago? All right, turn in your book to page 659. 659. By the way, if you did not submit the homework, you need to. And that was from yesterday. All right, so page 659. Let's turn there together. I want you to look at, I think they're only, we're going to do that whole page actually. So there is a long paragraph. Chaz, read that long paragraph off for me. If you struggle with some vocabulary, I can help you. Be nice.
A city is planning an outdoor concert for an independence day celebration. To hold speakers and lights, a crew of technicians set up a scaffold with 2 platforms by the stage. The first platform is 8 feet 2 inches off the ground. The second platform is 7 feet 6 inches above the first platform. The shadow of the first platform stretches 6 feet 3 inches across the ground.
Very good. Maybe some of you have been to a concert and you've seen this. Boy, I miss those days. Maybe once we all get vaccines, we can have this again. Scaffolding, right? And so it's kind of like a support system is what it is. But it's got 2 platforms. Here's the first one. They're calling that C. And they've got another one at the top. I'm not going to draw the whole scaffolding in. We've got A down here. We've got B here. We have D here. We have E there. Okay, and then we got some lengths. This length is 8 feet 2 inches. Then it says above that platform, I think is how Chaz read it. So that means it's in addition to that 7 feet 6 inches. And then we've got 6 feet 3 inches. Okay, I think we got all the distances. All right, now watch this. Now I want you to do this in your book, okay? We're going to separate. These triangles are laying on top of each other right now, okay? Well, first of all, are they similar triangles? They are. Because the A similarity postulate, we know angle A is equal to itself. These 2 lines are parallel because they're horizontal. You can stand on them. They're platforms. And so that makes these angles equal to each other. Okay? Because they're intersected by the vertical and then the angles. Okay? Does that make sense? So they are similar. All right, now, but here's what I want you to draw in. Go ahead and do this. Now, why am I doing this? Well, I think sometimes, not all the time, but I think sometimes it's a little easier to understand the problem when you separate the pictures, the diagram. So now we still have 2 triangles, but now they're not overlapping each other. They're separate. Okay, let's put all the lengths in there. AC is 8 feet 2 inches. Okay? AB is 6 feet 3 inches. All right? 7 feet 6 inches. If I add that, that makes this 15 feet 8 inches. And then we don't know what AD is. Okay? All right, look at number 14. We've already answered it. We've said that by the AA similarity postulate, they are similar. All right, let's take a look at 15. Mr. Johnson, can you read that off for me, please, Evan? Shadow of second platform. And it said in feet and inches? Okay. Here's what I'd recommend. Convert everything to inches. And then we can convert it back. Okay? Convert everything to inches, and then we'll convert it back. Okay, so the length of the second platform, that's actually, now look at this. This is the second platform right here. So what we have to find then is the length of the entire thing, which is AD, and then subtract away AB. That's what we got to find. That's the shadow of the second platform. Okay. All right. So here we go. Let's convert and make a proportion. 8 feet 2 inches. What is that? 8 times 12 is 96. 96 plus 2. That is 98. And that is to the big triangle. 15 times 12 is 180. That's 188. Okay. And then 6 feet times 12 is 72 plus 3. 75. And then we don't know what that is, and we're going to call it H or X or whatever we want to call it. That's our unknown. Wes, you good? Okay, cross, multiply, and divide. So 98 times H, and then 188 times 75. All right, somebody out there get your calculator going for me. Lily, you got yours? Okay, what's 188 times 75? I'm going to write that big number down. 14,100. Now divide that by 98. It's probably not an even number, which is okay. 143.87, like that. Okay, now, they want it in feet and inches. Okay, well, first of all, 143, that's not quite 12 feet, because 12 feet would be 144 inches. Does that make sense? Okay, so this is going to be 11 feet. So divide 143 divided by 12. What do we have? 11.989. Okay. So 0.989 plus, did you say 0.87? Is that what this is right here? 0.87. 0.87? Yeah. Okay, add those together. .859. That gives us another foot, doesn't it? So now we're at 12 feet, 0.859. How do I convert a decimal back to inches? Okay, this is how. Take 0.859. And then we know that there's 12 inches per foot. So basically take 0.859, divide it by 12. How many you get? Oh, I'm sorry. You multiply it by 12. Multiply it by 12. 0.859 times 12. Yeah, and it's not going to be exact. It's going to be a little off, but approximately 10 inches. Okay, and so we end up with 12 feet, approximately 10 inches. Now, that's not our answer, remember, because that's the entire distance. What do we have to subtract away? 6 feet, 3 inches. We don't know that it's exactly half. It's probably close, but it's not exactly half. So if I subtract away 6 feet, 3 inches, I end up with 6 feet, 7 inches. Thank you. Let's see how close we are to what the book said. Yeah, we're really close. They said 6 feet, 9 inches. Okay? Any questions? You see how to do all those conversions? It can be a little tricky going from decimals to feet, back to inches, you know. All right, let's take a look at 16. We got one more. I think we got room on this paper to do it. All right, 16 says, a technician is 5 feet 8 inches tall, standing on the second platform. Find the length of the shadow that is cast by the scaffold and the technician to the nearest inch. Okay, so let's put a person up here on top of this second platform. He's 5 feet 8 inches. So we're going to take this 15 feet 8 inches plus 5 feet 8 inches. That's 20 feet 16 inches, which is 21 feet 4 inches. All right, so that's the entire height. 21 feet 4 inches. Move this up so you can see that. Okay, so we have 21 feet 4 inches. That's the entire height. So this new triangle now is 21 feet 4 inches. Okay, so we still do a proportion. We're going to take this small one, but now we're going to go to the big one. Okay, and it's going to be the entire thing. So instead of 188, if I use the same proportion, instead of 188, it's going to be 21 times 12. Let's see, what is that? 20 times 12 is 240. 252? Yeah, 252 plus 4, so 256. Okay, so that's going to be 256. All right, Lily, back to you, calculator girl. 256 times 75 divided by 98.
195.9.
Go ahead and divide that by 12. Yeah, so I would say this is about 16 feet and 4 inches. Questions? We good? Does that feel? It's just what we got done doing, but just a lot more there because you got to think what sides are we comparing. I think this is a good habit to get into on some of these. That sometimes it's good to separate the triangles as you're looking at the picture. That makes sense. Okay, open up your. All right, hold on. Let me finish off. Thank you, virtual students. Check your missing assignments.